Hi, this is Pre-Calculus 12. This is an extra section for Chapter 5.8. We're looking at the time value of money, TVM, for real. What you have in the textbook does not handle all cases. So the payment periods don't always match the compounding periods. Okay, and that's the case in the book. And this is especially true for mortgages. Mortgages can only be compounded semi-annually in Canada by law, so you can't compound it monthly or any other values. Okay, and what we're used to dealing with is I. This is the advertised rate, also called the annual or nominal rate, and it does not include the compounding period, so it's nothing different than we've done before. R. This is the effective interest rate, and it's the annual rate or nominal rate, including the compound period. So this is a better rate for doing comparisons. We didn't do this. The formula for this is R equals 100 times, in brackets, 1 plus the interest rate percentage divided by 100C, which is the number of compoundings. And this 1 plus I over 100C is raised to the power of C, and we subtract 1. And then we multiply the whole thing by the 100. Okay, so your effective interest rate will be higher than your annual interest rate because there's compoundings in there. I. This is the interest rate per payment period. Again, if you're using the formula in the book, this was simply I equals the interest rate in percentage divided by 100C because the two matched, the payments and the compounding matched. However, if we don't have the two matching, the formula is I equals 1 plus I over 100C raised to the power of C divided by N, which is the number of payment periods in a year, subtract 1. Okay, so that's the only change we have. We can use the formulas just like we did before. So really, it's not much more work to do the correct calculations. So let's revisit 5.8.12. Each of two people has a mortgage of $200,000 with an annual interest rate of 3.5%. Person A makes payments of $500 every 2 weeks, and the interest is compounded semi-annually. This is correct for Canada now. Person B makes monthly payments of $1,000, and the interest rate is compounded semi-annually. Who pays off the mortgage first? So we have to calculate I. I equals 1 plus 0.035 divided by 2 raised to the power of 2 over 26 minus 1. Plug it in our calculator and we get approximately 0.001335540. And then we substitute our values into our present value formula. 200,000 equals 500 times 1 minus 1.001335540 raised to the power of negative n, all divided by 0.001335540. Okay, we're going to take these over to the other side, and we're going to have to flip them from numerator to denominator and denominator to numerator. I'm going to lop off a couple zeros here. So we have 2,000 times 0.001335540 over 5. Now that will equal this remaining bit, 1 minus 1.001335540 to the power of negative n. And I'm just going to swap sides here because this is minus. I'm going to make it positive. And this is just going to be minus on the other side. So 1.001 0.33540 to the power of negative n equals 1 minus, I'm going to do 2,000 divided by 5, that's 400, 0.001335540. Now we take the log of both sides, and we get minus n equals log 1 minus, and I'm going to take off a couple zeros here, take off a couple zeros here, 4.133540 over log 1.001335540. Okay, so I'm just going to change the sign here. That's going to be a plus, and it's going to be negative on that side. So now we can plug this in our calculator, get our approximate value. Okay, we're going to do negative log 1 minus 4 bracket 0.13354. Insert 3. And we need to close it off with 2 brackets divided by log 1.0013354 bracket. And we get 572.4. Bi-weekly payments. And we've done the work already on this one. Compare to 574.8. Save 2 payments. Okay, 2 payments of $500. That's $1,000 you save. Let's take a look at the other calculation. I equals 1 plus 0.035 divided by 2 raised to the power of 2 over 12 minus 1. That gives us approximately 0.00289,562. So we substitute into our present value formula. 200,000 equals 1,000. 1 minus 1.00289,562 to the power of negative n, all divided by 0.00289,562. We're going to do a bunch of similar work, and we're going to end up with n equals negative log 1 minus 200,000 divided by 1,000 gives us 200. And we still have the 0.00289,562, all divided by log 1.00289,562. That gives us approximately 299.3. Compare to 300.6 monthly payments. So you save over a month of payments, and that's over $1,000. Now, almost nobody solves this by hand, and almost everyone just uses the Tvm solver on a calculator. I would use this to check your answers on a test because you need to still show your algebra. So how do we do this? So we go to Apps, Finance, Tvm Solver. Okay, so our problem, we have 3.5%, and our present value is $200,000. We're making payments of $500, and we have to make negative payments. Okay, our future value is 0. our payments per year is 26 and 26. And we want to calculate our N. So we go up here and we go alpha sol. And we get our 574.8. Okay, all we have to do is jump down here, change our compoundings to 2, and go back up, and second sol. And we get our 572.4, which is right here. Okay, so that's how that works. Let's use the Casio for the other solution. Menu, TVM is here, so we just press the C key. And we're doing compound interest. Okay, so let's enter this again, 3.5. Our present value is 200,000. This time we're doing our monthly calculation, so our payment is negative $1,000. And we have 12 and 12. Okay, and we want to go up and calculate N. So I press F1, and we get 300.6 monthly payments. We press exit to get out. We want to change this to a legal 2 compoundings per year. Go back up and press N, and we get 299.3. Okay, so that's how we use the TI and the Casio TVM solver. And if you're going to do payments into compound savings, you need to do an adjustment, and your payment are going to be at the beginning. Okay. Okay, we press Shift and Setup, and then we can change the payment period to begin with F1. And that completes this lesson.